Welcome to the module K-3 Meaningful Math Practices. In this module, we will look at strategies for embedding the Common Core math practices into daily instruction. And because number concepts, the number sense, place value, problem solving, these are major works for grades K through 3, everything that we're going to do today will be related to these concepts, to these number concepts. The expected outcomes for today are going to be to examine the Common Core math practice standards, to engage in strategies that promote the use of each of these standards, and then you'll have some time to create some ready-to-use activities for your classroom. Before we actually get into the activities and digging into each of the practices, I wanted to remind you why we have these practices. It is the intention of the Common Core Standards for Mathematical Practice that these guide our math instruction. All or most of these practices are embedded into each lesson that we do daily. And the nice thing about these practices is that they're the same for all grades K through 12. So if you're focusing on these practices at the kindergarten level, your students will be really proficient by the time they get into 5th grade. And the practices focus on the process of learning, not just finding the answer. So no longer is it enough for the teacher to say, oh, okay, the answer is 12, let's move on. No, we need to dig a little bit deeper, talking about the reasoning, the sense-making, focusing on how did you select an appropriate tool, or the communication, not just that answer as the end-all be-all. Well, the first practice that we're going to discuss today is make sense of problems and persevere in solving them. This practice asks us to do more of a close reading on problems. So reading those problems carefully, really understanding the question being asked, not just using one of those problem-solving strategies where we're boxing the question, but really understanding the meaning behind that question. So once you do your close reading and understand what the problem's asking, then you're going to determine the appropriate solution strategy, try it out, see if it works. If it doesn't work, then pick a different strategy. And then after you get a solution, make sure that that solution is reasonable. One thing that I wanted to address related to this practice is what it takes for a student to solve a problem correctly. Anytime students are faced with a problem, they need to be able to read the problem, understand what was read, and transform those words into a problem-solving strategy, and then actually apply that mathematical procedure then to get that answer. But what's happening is that over 50% of the errors that kids are making are occurring in these first 3 things before the students even operate on the numbers within that problem. That means that something's going on where the students aren't truly comprehending what's being asked, and it's not within the operating. So we want to really focus on finding a problem-solving strategy that rectifies these issues. So let's talk about, well, what's causing these errors or these issues. One thing that could be causing these errors is that sometimes teachers overly focus on keywords. Those are the words like, oh, well, when you see all together, you add, or when you see difference, you subtract. But this strategy is limited because those keywords don't help students understand the situation and don't focus on a deep reading or a close reading of the problem. Keywords can also be misleading because there's no guarantee that they'll always mean that same thing. They might mean different things in different situations. So when we teach students a problem-solving strategy, we really have to focus on a strategy that is really focusing on understanding the problem more deeply. Before we get into a really good problem-solving strategy that I would recommend, I wanted to talk a little bit more about keywords. Take a look at the following 3 problems. The first problem says, Jenny has 6 seashells. Susie gave her 18 more. How many seashells does Jenny have? So here we're seeing the word more, and typically teachers will tell students that when they see more, they're going to subtract. How many more, or how many less. But really, she's saying, now that Jenny has received more, how many does she have now? So we're actually adding. So here's one example of where a keyword could be misleading. Here's the next problem. Billy has 14 baseball cards. How many more does he need to have? 31 in all. So how many more? So here is that word more again, but this time we're trying to figure out how many more does he need. So you really are either using some counting on or some subtraction here. So different than that first problem. And then the last problem says, Ryan has 75 bottle caps in his collection. Jackson has 43. How many more bottle caps does Ryan have than Jackson? And that's traditionally how we'll see that word more used. And again, in this situation, we would be subtracting. So focusing on the keywords, like we said, could be misleading. So now let's take a look at some problem-solving strategies that we could be teaching in our classroom. Let's start by taking a look at this problem-solving strategy that I've seen frequently on Pinterest and Teachers Pay Teachers. Let's put a problem in front of us so we can practice using it. This strategy says to circle the key numbers. Okay, so we'll circle those numbers. Then it asks us to underline the question. Okay, we're underlining the question. Then it says to box any math action words. And when I dug a little bit deeper on Teachers Pay Teachers, I found out that the math action words are actually another way of saying keywords. So let's look and see if we see any keywords. I'm going to box in all here. And then it says evaluate. So what steps should I take? So, okay, now I'm seeing in all, I'm seeing some numbers, and I'm going to go ahead and add these two numbers. But this strategy is actually not very helpful to me because you'll notice we did the C, U, and B without even reading this problem. We never dug in and did a close reading. So when it came time to E, to evaluate what we should do, we looked at all of this stuff that we wrote on the problem and we decided to solve the problem incorrectly. So this is probably not a problem-solving strategy that you want to use. Let's take a look at a strategy that really focuses the kids to dig in a little bit deeper. Here's another strategy. This is the stop sign strategy, and this probably is familiar to you. In this strategy, you're going to read the entire problem, but do not solve it. Don't even stop to do anything with it. Just read it to get a gist of it. Okay, so Billy has 14 seashells. He wants to collect 31 in all. So how many seashells does Billy need to find? Okay, so we read it once. Next, we're going to reread the problem. Hold up your hand every time you see a period, comma, question mark, the word and, or the word but. This is kind of obnoxious to some teachers, and I find it obnoxious too, but it's really, the kids get a kick out of it because you'll tell them to hold up their hand and the kids all shout, stop, and then they can take some notes at each stop or draw a picture at each time they stop or highlight any important information. It really forces the kids to dig in each step of the way in the problem. So we're going to keep stopping and taking notes or drawing pictures or highlighting each time we see a comma, period, question mark, and, or but until the problem's completely read. And then we're going to solve the problem. And after we solve the problem, then go back and see if our answer makes sense. This really focuses the kids into doing that close reading and doing the thinking into the problem a little bit more. One last thought about this problem-solving strategy. I would really suggest that your schools have a school-wide problem-solving strategy, just so that once it's introduced in kindergarten, the first grade teachers can continue it and they're not trying to start new with a new strategy. By the time the kids get into 4th and 5th grade, then they could really dig into the problems and just focus on the problems, and the teachers won't have to spend as much time teaching the actual strategy for problem solving. Now that we've taken a look at a problem-solving strategy that we could be using actually with a K-5 student, let's look at some types of problems that we can be giving our students. This strategy actually could be used any grades K through 5. This example is probably a first grade example. But digging deeper is just a way for teachers to use the same information across the week in order to get kids to dig deeper into the mathematics. This idea or this strategy could be used to review a skill over time. So what you would do is you would show students the same chart or the same set of data or numbers or the same graph all week long, and then each day ask the students a different question. This way the kids are spending less time trying to navigate through new information, and they're spending more time with the mathematics. It's kind of like a close reading. On the next slide, you'll have a chance to look at a couple different types of digging deeper problems. So throughout the discussion of the practices today, I'm going to give you an opportunity to explore some related activities related to what I'm teaching. At this point, we're looking at practice 1, so I'm going to give you a chance to go to this Symbaloo. So if you want, you can pause the video and open up another window, and you would go to www.symbaloo.com/mix math practices. And at this point, we're only going to visit practice 1, which looks at the example of the stop sign strategy, and then some different types of problems for digging deeper. When you're done exploring the symbol just for practice 1, those orange icons, then you can come back to the video and we will continue. This next practice is a bit tricky to understand. There's a lot of heavy math terms in here, but basically what the practice says is to reason abstractly and quantitatively. That just really means that if you have a situation, you can use math to represent it. So you can pull out the mathematics of that situation and, for example, just use an equation to represent it. It asks us to have students think about the numbers and units within a problem, or pull those numbers and units out of a problem. And then it has these two terms, decontextual and to contextualize. That just pretty much means that when we're decontextualizing, if we have a situation, we're able to pull out the math and just work with those numbers, or just work with the quantities or the operations. And then contextualize says, okay, now we have these numbers, let's put them back into that context to see if it makes sense. So again, just pulling out the quantities and operating, and then putting them back to make sure that they make sense. And typically students really have a hard time focusing with that on that second part of seeing if it makes sense. They typically leave that part off. So one strategy that we can think about for decontextualizing, which is just pulling the mathematics out of a situation, is pinch cards. And basically what this is just an index card that has the addition and subtraction sign, or for third grade, addition, subtraction, multiplication, division symbols on them. And then the students would pinch or touch the operation that is being described in the situation. This would also lead to some good conversation, because sometimes more than one operation could be used to solve a problem. So let's take a look at a couple problems. 7 ducks are in the pond, 3 more get in the water. How many ducks are in the pond right now? So the students could touch or pinch the part of the card that has obviously the addition sign in there. Here's another one. 5 apples are on the table. I ate 2 apples. How many are on the table now? And students would probably think of that as a subtraction problem. And then here's another one. 2 black ducks were swimming in the pond. Some brown ducks went into the pond. Now there are 10 ducks. How many brown ducks went into the pond? Now here's something interesting. Some students might say, well, I would subtract to find that, and some students would say I would add to find that one. So this could lead into some good conversation, which is actually related to another practice as well. And let's do one more. 5 apples were on the table. I ate some apples. Now there are 3 left. How many apples did I eat? And again, this could be solved with subtraction, but some students might say they counted on or used some form of addition to solve this problem as well. The pinch cards we just talked about really focused on decontextualizing, which is pulling the mathematics out of a problem. This type of situation that we're looking at here, the missing info task, really focuses almost more on contextualizing, where the students are being able to put numbers back into the situation and then see if it makes sense. So what you would do here is just remove, take a word problem, add the last statement, which is the answer statement, and then give the students that entire word problem, but just remove all the numbers. So what I did was I just took a textbook problem here and then made one more statement that answered the entire problem, but then I removed all the numbers, and the students have to reason through to see what makes sense, where the numbers would go. So if I was reading this problem, I might see, oh, okay, I see right here, wow, that's blank bugs and all. So I might start by thinking about, well, okay, well, most of the time when I see in all, I might think of the term addition. Let me see if it works in this situation. So I might put the biggest number here, which is 6. And then I might look through it a little bit more, and I might think, okay, well, blank bug flew away. Well, because there's no S there, I might put the number 1. So I'm just kind of reasoning through and seeing what makes sense. Okay, so now let me go back and read the rest of the problem and see what else I can plug in. First, Kate only caught, maybe I'll try 2, because she only caught, so it might be a small number. So first she caught 2, and then she caught, let me see, 4 more. Okay, so 2 and 4, so she caught 4 more, so that makes 6 bugs in all. Okay, well, that works so far. Oh no, 1 bug flew away. Okay, so now she has 5 left. Okay, that makes sense. This really also focuses on that persevering in problem solving, because the kids can't just take the numbers and do something with them. They really have to persevere, problem solve, and make sense of this problem. Again, for practice 2, we have some sample activities on our Symbaloo. So if you want to take a moment and pause the video, go to the Symbaloo on your other page and try out a couple of the missing info activities. Look at the pinch cards, look at some sample questions. If you want, you can even take some time to create your own activities related to practice 2. When you're ready, go ahead and just press play on the video again. Well, practice 3 asks us to construct viable arguments and critique the reasoning of others. So this is almost that math talk that we've mentioned before in other modules. Students have to make and test conjectures, or make rules about what they think happens in math and test those rules. They have to be able to explain their thinking. But then they have to listen to others' ideas and decide if those ideas make sense, and then ask others useful questions to make sense or to test out their thinking. So like we just said, Math Talk is a great way to do this. So with Math Talk, it's an opportunity for students to learn, for students to explain their thinking. Students are asked to justify their solutions, to ask each other questions, and then to prove or justify their answers. This dialogue helps students gain a deeper understanding, and it also helps them think about what they actually did during problem solving and not just focus on the answer. During all of this, the teacher is just going to act as that guide or facilitator to help students focus in on the task at hand, and the teacher can ask clarifying questions as needed. So during the math talk, there's 5 things that we want to make sure that the teacher is doing here. And these are called the talk moves. The teacher, primarily what the teacher will be doing is she will be revoicing what students say. So if we are solving a problem and a student is explaining their solution, the teacher might start by saying, okay, so let me make sure I heard you right. What you said is, and then she would revoice what the students are saying. The next part of this is asking the other students, or 1 or 2 other students, to repeat what that student said. So revoicing is what the teacher's doing. She's repeating what the student says. And then that repeating part is what the other students are doing. Johnny, would you be able to repeat what Susie just did here? And then going back to Susie afterwards, Susie, is that indeed what you said, or do we need to change it a little bit? After that, then we ask the students to reason about what Susie did. Do you agree with what she did? Do you disagree? Let's talk about her thinking. We also want to make sure that we allow others to add on. Once you get into the swing of doing math talk, a lot of times students will say, can I add on to that? I did the same thing, but I also did, or I did the same thing, but then at the end I did this differently. The last thing that we really want to make sure we're doing during math talk is to allow for wait time, even if it's painful. And I know we say that a lot, but really the research shows that students' amount of answers will increase, the students' quality of answer will increase just by allowing a couple extra seconds of that wait time. If you're interested in learning more about Math Talks, this teaching channel video is a really great illustration or a great snapshot of a teacher using Math Talks to improve student participation. So if you get a chance, go to this teaching channel video and see how this teacher was successfully using Math Talks in her classroom. One other strategy to increase the amount of talk time and the quality of communicating and justifying answers in your classroom is to get students to be thinking about which one of these things is not like the other. If you are interested, I have a link to the actual song from Sesame Street, One of These Things is Not Like the Other. It's at the bottom of this screen right here. You can copy that. But what the purpose of this is for students to examine 4 things and then have to explain or justify why they think one is different. Sometimes there might be only one right answer. Sometimes there might be more than one way to look at something. In this image, or in this illustration right here, there are 4 different quantities, or 4 different cards. They have a different number of dots on each, or a different arrangement of dots on each, and students would be asked to look at this and say which one they believe is different. When I've looked at this with teachers, they've said different responses. They've said, well, most of them are composed of 2 sections or more than one group, and then the one at the bottom right is only composed of 1 group. So that's how they looked at it. What I was thinking was that all of them have 6 dots except for the top right one. But through those talk moves, that math talk, you could dig a little bit deeper and get students to explain why they think one of these things is not like the other. And again, this was the one that I was hoping students would think is different than the others. Another way of looking at this is to do the activity odd man out. This activity will be on our Symbaloo, and you'll have a chance to look at it. So what you would do is you would give the students 4 different things on an index card, a large index card or a half sheet of paper, and they would have to figure out which one is different, represents a different quantity than the others. Then you would have a separate odd man out card, and I just put that card behind it. And when you put the odd man out card behind your index card, the hole punches next to your 4 answer options are going to be shaded in with colors. The one that is shaded in different represents that odd man out, or the thing that's not like the others. Hopefully that made a little bit of sense. Again, when you do this activity, when you take those half sheet cards, you would punch holes next to each of the objects, each of the things, and the hole that is the different color would be the one that is the different quantity. The template on Symbaloo will help you do this. The holes will already be pre-marked so that you can just change the problems. Well, now that we've talked a little bit about some resources for practice 3, you'll have a chance to go on to the Symbaloo. We do have a Math Talk poster here. We have that video that addresses the different talk moves. And then we have, I mentioned dot cards, or those cards on that one of the things is not like the others. So we have the template for those. We also have some templates for the odd man out activity. So again, pause the video, take some time to explore these resources, and press play when you're ready to move on. Practice number 4. Practice number 4 focuses on modeling with mathematics. Typically when students think of modeling, or when teachers think of modeling, they think of pulling out manipulatives. But this is actually a lot more involved than just pulling out some math manipulatives. What we want students to be able to do with this practice is we want them to use math to represent problems in the world. So they're using their math to model real-life world problems. They're explaining situations by using objects or different models, objects, drawings, symbols, and words, and then they're able to make connections between the models. It's one thing for students to be able to model something with one representation. It's a whole lot more deeper and more difficult for students to see the connections between all the different representations. We'll talk about this over the next couple slides. This image comes from the article, A Model for Understanding, Using, and Connecting Representations. But what I wanted to point out about this is these are all the different ways that you can model something within mathematics. So you might model an idea or a situation using pictures or manipulatives or symbols like an equation or spoken word. Or if you're given written symbols like an equation, you should be able to model that equation with a relevant situation. And then besides being able to do all of these different models, students should also be able to see how they connect. And it's the teacher's job to show the relationships between representing a situation with a picture and connecting that picture then to the equation representation or the modeling of that situation. Here's an activity that focuses on modeling and making connections between the different types of models. And I actually did this activity on a daily basis during my calendar math when I taught kindergarten and first grade. It's called Climb the Ladder. For each number of the day, or for the date for each month, I would have the students write the date at the bottom. So just write the 23rd, for example, or 24, and then I would have them draw a picture for that representation, use tally marks, write it in the word form. I might have them take base 10 blocks and build it, and then write an equation. at the beginning of the year, obviously we didn't do all of this. Each rung of the ladder gets increasingly complex. So we might start off just with the bottom 2 rungs. And I would take this on cardstock, have it laminated, and then just use vis-a-vis markers so the students could just use the same board every day. One thing that I also did was, once introducing the equations, I tried to represent a variety of types of equations at the top. So I might do the total is equal to the part plus part, or sometimes I would have the equation say part plus part equals the total, or sometimes I would have subtraction equations as well. Another way for students to model is Common Core asks us to have students think about meaningful situations to represent a given equation or a given quantity. So you can have them create headline stories. And what this means is, typically a headline in a newspaper is just a really quick, short snapshot that sums up the story and is catchy. So one example of a headline in mathematics might be an equation, because again, this is just a short snapshot or a summary of what that whole math story might be. So if you give the students the equation as their headline, they would have to come up with a meaningful context or meaningful situation to represent that equation. And again, in our Symbaloo, there's a couple templates for doing this. Representing numbers is one more type of activity that encourages multiple models or representations of a mathematical term or quantity. So you would tell the students that as a table or as a group, they're going to decide on a number to write in the middle of their poster of their paper. Then they would rotate to the other tables or groups, and at each table they must find a different way to represent their number. So if the number was 23, students might say 21 plus 2 equals 23, or they might draw 23 dots, just any type of representation for that number. As we're thinking about the different ways that we could represent numbers, we could do tally marks, base 10 drawings, money, numerals, words, dots on the dice or dominoes, 10 frames, equations, pictures, number lines. Really, there's limitless possibilities. Well, now that we've discussed practice 4, you can take a minute to explore the resources on our Symbaloo. We have a couple options for the climb the ladder activity and a couple templates for the headline stories. And if you would like, you could also create some sample activities to use in your classroom using these templates right now. Go ahead and pause the presentation, and when you're ready to continue, you can press play. The next practice that we're looking at is using appropriate tools strategically. This practice asks us to decide which tools will best help me solve a problem. It also asks us to make estimates before actually using the tool. This way, if we make a mistake with the tool, then we already made the estimate, so we kind of know what to expect. This is especially good when using a calculator because you might hit a wrong button and you might have a ridiculous number. If you make an estimate first, then you know that your number is ridiculous and you don't just blindly write that number down as the answer. And then lastly, like we just said, compare that estimate to the answer to see if that tool was effective in helping you solve problems. Well, I wanted to start by pointing out that there's 3 types of tools. There's concrete tools that the students can physically manipulate, representational tools like number lines or more drawn tools, and then there's abstract tools as well. And I think teachers and students often forget that they can actually use their brain as a tool, and hopefully they are relying on that. Whenever we introduce tools, we typically want to start with those concrete tools at the beginning of a unit, hoping that eventually we can move towards more representational or drawn tools, and then eventually one day moving to those abstract tools. An example of an abstract tool would just be like a mental math strategy of using doubles or different making tens when you're solving addition and subtraction problems, that type of thing. What I wanted to do was give you just a couple examples of possible tools that we could use at the K2 or K3 level, and think about, are these concrete? Are these more drawn tools, or are these abstract tools? So the first tool I wanted to highlight was just break apart sticks. This is a great tool for the K1 or even K2 level. And you would start by building a set. So for example, there were 10 birds in the sky, so I would build 10. 4 were blue and the rest were black. So if I wanted to find out how many were black, I could break apart the 4 that I know and realize, oh, okay, there's 6 left, so there's 6 that are black. So if we're thinking about concrete, representational, or abstract, I would probably say that's a concrete tool because you're physically manipulating it to solve a problem. Here's another example, a math mountain. So Max's mom baked a batch of cookies. Max ate 3 cookies and there were 3 left. So how many cookies did Max's mom bake? And again, the students are using the double-sided counters like they did in the previous problem, but here they're looking at the part, and then they're moving it together to find the whole amount. So looking at the math mountain as a part, whole type of tool. And again, thinking about, is this concrete, representational, or abstract? I think it depends. If you're using it with like a work mat with double-sided counters that you're physically moving or manipulating, we could say it's concrete. But then eventually students might be able to use just a representation of this tool, just a quick drawing, and obviously that would be representational. Here's another type of tool. This is a number balance. I think this one is through ETA Cuisenaire, but it says there were 10 birds in the sky, so that same problem. 4 were blue, the rest were black. How many were black? So we know 10 is the total. So on the left side we could put the total, and then we could put, we know 4 are blue, so we would put 4, and then we would try different numbers until we get it to balance to find the other part. And again, is this concrete, representational, or abstract? I would say this one is definitely concrete because you're physically moving the tool to get a solution. Another really good tool is a 10 frame. I'm not going to talk too much about this, but LearnZillion.com has a really great series of quick, just short video clips just teaching how to use a different tool or different strategies, and they have some really good videos on how to use the 10 frame. So I won't talk too much about that one today because I think most teachers are familiar with the 10 frames. But pretty much 10 frames could be concrete if you're physically manipulating them. And again, they could eventually be representational or pictorial where the students might just be drawing a quick picture to help them. But probably for the most part, this would be more of a concrete type of strategy. Another tool that students could rely on are bar models. This problem says Fred earned $97 at the rock quarry. The Great Gazoo gave him $49. Now we want to know if Fred had enough money to buy the record player for $150. So Fred earned $97. The Gazoo gave him $49. Did he have enough money for the $150 record player? Again, is this concrete, pictorial, or representational, or is it abstract? I would say this is more of a representational problem where the students are they are drawing a representation or drawing a model to represent those quantities and considering the magnitude or the size of the numbers as they draw that model. So this might be for maybe second graders. They're moving away from concrete tools and they're moving into more of those drawings. Another example of a bar model, Barney is 52 inches tall. When he puts on his Water Buffalo Lodge hat, he is 63 inches tall. How many inches taller is Barney with his hat? Well, let's look at this. Barney's 52 inches tall. With the hat, he's 63 inches tall, and we want to know that difference. So again, these tools are more pictorial, where the students are drawing these and using these bar models to help them solve the problem. Again, back to LearnZillion. LearnZillion does a really good job of teaching mental math strategies, especially the second grade videos. And this video highlights the doubles facts. Well, if I know 8 plus 8, then that can help me find 8 plus 9. This is more of a mental tool or abstract tool, so using our brain as that tool for problem solving. And this is where we eventually want students to move after they've really relied on those concrete tools or those representational or drawn tools. Now that we have talked a little bit briefly about the different tools and talked about Practice 5, I'm going to give you a chance to explore some of those LearnZillion videos. There's a couple other components that I'd love for you to explore. One is Dreambox, and then there's some different virtual tools here. So take some time to pause the video, go back to our Symbaloo, and then press play when you're ready to go on to Practice 6. Practice 6 asks us to attend to precision. So this is, the first part of this practice is, well, when do we attend to precision versus when do we estimate? Another part of this practice is making sure that we attach units to numbers to make those numbers have sense and meaning. So making sure that we are saying not just 4, but 4 bricks or $4, whatever that unit is. And then using appropriate vocabulary. And that means the teacher needs to be modeling appropriate, precise vocabulary and holding students accountable for that as well. A couple activities that we can do with students. We could talk about, well, when would you want to estimate versus when would you find the exact amount? And here's a couple examples of that. I measure ingredients when I bake cookies, and I decide how many cookies to bring in for my class. So which of these would you probably want to estimate and which would you probably want to have exact measures? Here's another example. I make sure I don't spend more than $20 at the store, and the cashier tells me how much my items cost. So here, obviously, you probably will do some pretty good estimating to make sure you don't go over 20 at the store. But when that cashier tells you the total of your bill, she's going to give you an exact calculation. And one more example. I'm going to measure the doorway of the classroom so I can buy a new door. And then the other statement here is I want to make sure I buy enough tiles to cover the kitchen floor. Well, with this one, you probably want an exact measurement when you measure the doorway, because if you don't measure exactly, the door won't fit. But it's okay if you overestimate when you estimate the number of tiles that you will need to cover your kitchen floor. Or if you underestimate, you can always go purchase some more. So another activity that you can do related to attending to precision with students is to ask them to think about the unit. I remember when I was in elementary school, I never understood why the teacher would always say, make sure you label the unit when you're writing your journal entry. Don't just say 4 because I won't know what you're talking about. But I never got that because I always thought, well, the teacher wrote the problem, so she should understand what I'm talking about. But there's a deeper meaning behind why we use that unit. The context of a situation can change drastically based on the units. So looking at this problem right here, it says 20 fell from the sky and hit me in the head. Then 10 more fell right on top of me. Wow, that's 30 in all. Notice we don't have units here. So we talk about, okay, let's talk about what the unit could be and how it changes the meaning of the situation depending on what unit we use. So that unit could be feathers. Well, that's fine. Feathers fell from the sky and hit me in the head. That's not too painful. Or books, that might hurt a little bit more. 30 books hitting you on the head. Frogs, that's just kind of disgusting. And then $100 bills or money, which I wouldn't mind hitting me in the head if it's falling from the sky. So thinking again that unit can change the meaning of the situation drastically. So then one activity you can do with this is give students word problems and just have them think about what is the unit. So not even really having them solve the problem just yet, but just having them tell each other what the unit is. And you could do this as a quiz trade, where each student is given a problem. They read the problem to a partner, and they quiz the partner on what is the unit, and then the partner quizzes the other partner, and then they would trade cards and find a new partner. Hopefully that makes a little bit of sense. Let me give you an example. I might read this problem to my partner Susie, and I'd say, Susie, what's the unit in this problem? And she would answer me. And then Susie would read her problem, and she'd say, Dawn, what's the unit in this problem? And I would answer her. Then we would trade cards and find another partner. And then this way, each time we quiz another partner, we're quizzing them on a different card, so it's getting us to see several different problems. Now that we have talked about some strategies for practice 6, let's go ahead and go back to our Symbaloo. On the Symbaloo, we have several different word problems here so that students can practice doing that quiz trade. So if you want, you can take a minute to explore the word problems, and if you want, you can take some time to print some word problems out or create your own for your classroom. Practice number 7 asks us to look for and make use of structure. Practices 7 and 8 are the most complicated, and even the president of the National Council for Teachers of Mathematics said at the elementary level she doesn't really see a huge distinction between 7 and 8. So chances are at the elementary level, if you're using practice 7, you're using practice 8. Practice 7 just asks us to find structure or patterns in numbers, so kind of thinking about how the numbers work, noticing the reason why patterns might happen in mathematics, and a lot of times I think about the hundreds charts or the multiplications chart, so noticing why these patterns start to happen. Once we notice that these patterns are happening, we should be able to start to make rules about mathematics, so rules about what will happen in mathematics, and then we should be able to use these rules to help us solve some problems. Let's talk a little bit more about what this practice is. One example of this is properties. Properties are things that always happen in math, and students at this level, at K through 5, don't need to know the names of properties, just how to use them. So just noticing when they happen, and then using those properties to then help take shortcuts and help them solve problems. So what you could do with this is ask students to solve the following two problems, 4 plus 3, and then 3 plus 4. And the teacher might say, oh, look at that, same answer for both of those. Let's move on to another example. 5 plus 6, and then 6 plus 5. And the teacher says, well, that's a coincidence. Okay, let's do another example. 7 plus 2, 2 plus 7. Well, that's interesting. Then you would ask the students, well, what do you notice happening here? Because there is a bit of a pattern here. Or then after they notice what happens, say, well, what conjecture, what rule do you think we can make based on what we noticed here? And do you think this rule will always work when we're adding two numbers? So then after the students have made some observations and made their rule or made their conjecture, the teacher would record their conjecture on the board. And the teacher would say something like, okay, so what I'm hearing you say is you will get the same answer no matter which order you add two numbers. Even if the students create an incorrect conjecture, the teacher should record it. And the reason for that is as they test this out with other examples, they might fine-tune this rule or this conjecture, and the teacher can revise the rule as they go on throughout the lesson. After this, the teacher would say, well, how will knowing this help you in math? And you can talk about that. And then there's a couple more problems or a couple more questions the teacher could use to really dig in and turn this into maybe a day or 2 days or 3 days worth of instruction. Some possible follow-up questions to get students to dig a little bit deeper and explore their rule a little bit more. Can you think of an example where your rule won't work? Using addition, obviously. So students would try to find, you would challenge students to find an example where this rule wouldn't work. Will your rule work with really big numbers, and how do you know? And then will your rule work if you're adding 3 numbers or 4 numbers or 5 numbers? So the students would spend some time trying to find out the answers to these questions using other examples. After you're done with this, you might ask the students, well, will your rule work with subtraction? And they could test that out. You could also discuss with the students, after obviously exploring this concept for a bit, then you would say to students, mathematicians have actually discovered this same rule that you discovered today, and they named it. And the mathematician name for this is called the commutative property. And that's probably all I would say about that term, commutative property, because I don't care if students know the commutative property. Common Core doesn't care if they know that word, commutative. But what they do care about is understanding how this rule works, why it works, and how we can use this to help us in math. Another example of attending to structure or thinking about what happens in math, the patterns, the structure within math, and using this to help us solve problems is to look at a hundreds chart. And what you would do is do kind of a number talk where, okay, let's add 40 plus 10, and the students would use their numbers, their hundreds chart, or they would use mental math and then check their answer on the numbers chart. 40 plus 10 more, okay, well that's 50. Let's add 40 plus 20. Okay, that's 60. 17 plus 10, that's 27. And eventually the students would realize that when they're using the numbers chart, they're jumping down. They're just jumping down a line because each time they jump down, it's adding 10 more. And they can use this to help them take shortcuts here. This also leads to mental math, because through frequent practice of this, students will be able to start to take shortcuts and use mental math strategies based on noticing these patterns here. At the end of doing a number talk or a problem like this, you probably also would want to challenge them to think about something a little bit differently at the end of the lesson. So here I put in one more problem, and now we're thinking about subtraction, and they would move up on the hundreds chart instead of moving down. Under practice 7, you have a couple activities that you can explore. Some of these just have hundreds charts or multiplications charts for 3rd grade, so take some time to explore those. See if there's anything that you can create right now or print for your classroom, and when you're ready to continue, press the play button again. Our last practice, practice 8, asks us to look for and express regularity in repeated reasoning. This practice is very similar again to practice 7. It asks us to look for patterns when working with numbers and observe when things repeatedly happen, when calculations are repeated, and use these observations to take shortcuts. When I think about this practice, I think about when we multiply or divide by 10, 100, 1000, and how that decimal point just shifts, and how knowing that as adults, we typically use that to take shortcuts when we're computing. I also think about number talks, like how you can talk to students about, okay, 10 plus 10 is 20. Well, what's 10 plus 9? Well, if I know 10 plus 10 is 20, one less than that I know is 9. So instead of physically adding 9 to 10, just using what I already know and taking a shortcut. Let's talk about what is the difference between practices 7 and 8. Practice 7 asks that we notice patterns in math, we realize that these things will happen, will repeat themselves, and we recognize that math has this structure or this system, and these rules will always work. So now practice 8 asks us that once we recognize these patterns or the structure or these rules, we just use that information to help us take shortcuts. Now this isn't focusing on quick tricks of just here's a shortcut, memorize it and take it, but it does focus on getting the students to notice things and getting the students to say, oh, well, since I know that, I can use that to help me and to take a shortcut. What we're going to do right now is take some time to go back to those activities from practice 7 on your Symbaloo and think about how could you also use these activities to address practice 8. Lastly, what I wanted to talk about was on the Symbaloo there are 2 activities related to place value at the very end. I wanted you to take some time to think about which activity provides a more valuable learning experience, which activity allows the teacher to build in more math practices, versus which is just a very procedural, bland activity where really none of the math practices could be built into it. As you think about this, just think about the activities that you're currently doing in your classroom and the activities that you could build practices into versus the activities that you might want to take out of your repertoire so that you are focusing more on those practices. Like I said, those activities for the place value are in red at the bottom of our Symbaloo. You can take some time to explore these activities. I'm going to wrap up here. I thank you for participating in today's module, and hopefully you will find this Symbaloo useful in the future since it will be posted continuously. So this is a link that you will be able to access. Have a good day.